the silence that hides the danger. Out there in the void, in the cold, endless darkness between stars, danger lurks in silence. No warning, no sound, no glow. Just a flash, a ripple, a burst, and everything could change. We live on a fragile blue planet, protected by a thin atmosphere and an even thinner sense of security. Most people look at the night sky and see beauty, but astronomers see more. They see motion, force, energy, and threats. Invisible threats. What if, at this very moment, a high-energy gamma-ray burst is heading toward Earth? What if an ancient black hole, undetected, is drifting closer than we think? What if solar storms or cosmic radiation are already affecting life without us even knowing? In this documentary, we explore the hidden dangers of space, the threats we can't see, can't touch but can measure. From distant cosmic events to silent particles passing through your body every second, we ask one critical question. Are we really safe in the cosmos? Or is our world more fragile than we imagine? A universe full of energy. Space is not empty. It's a dynamic, chaotic ocean of particles, radiation, and gravitational forces. Though our senses perceive the vacuum as serene and still, the universe is alive with energy, most of it invisible to the human eye. Our planet is constantly bombarded by particles from space neutrinos, cosmic rays, solar wind. Every second, trillions of neutrinos pass through your body without leaving a trace. They come from the sun, from stars, from events billions of light years away. But not all cosmic visitors are so gentle. From the most violent events in the cosmos come some of the most dangerous forces. Gamma-ray bursts, magnetar flares, rogue black holes, high-energy cosmic rays, and coronal mass ejections are just a few of the phenomena that could impact Earth, some catastrophically. Gamma-ray bursts, the silent apocalypse. Gamma-ray bursts GERBs are the most powerful explosions in the universe. When massive stars collapse or neutron stars collide, they can release narrow beams of gamma radiation traveling near the speed of light. If Earth happens to be in the path of one of these beams, the effects could be devastating. GERBs can strip away our atmosphere, destroy the ozone layer, and expose the surface to deadly ultraviolet and cosmic radiation. Mass extinctions on Earth, like the Ordovician extinction, may have been triggered by such events. The terrifying part: GERBs happen all the time. Most are far enough not to hurt us. But a close one, even from 6,000 light years away, could be catastrophic, and we would never see it coming. Rogue black holes, the invisible travelers. Black holes are often portrayed as monsters in science fiction, but real black holes are even stranger and more elusive. Most black holes are born in supernova explosions and remain in place, quietly distorting space around them. But some are moving. Rogue black holes, kicked out of galaxies by gravitational interactions or collisions, wander the universe invisible, undetectable by light. If a stellar mass black hole passed near our solar system, it could disrupt planetary orbits or slingshot comets into Earth's path. If it came closer, it could strip Earth from the sun, or worse. There may be millions of these dark wanderers out there. We don't know where they are. We don't know if they're coming. Solar flares and coronal mass ejections. While distant space poses serious threats, our own sun is no less dangerous. Solar flares and coronal mass ejections, CMEs, are eruptions of charged particles from the sun's surface. When they hit Earth, They interact with our magnetic field, producing beautiful auroras and chaos. The Carrington event of 1859 was the most powerful geomagnetic storm ever recorded. Telegraph systems failed, sparks flew from wires, and northern lights were visible in the Caribbean. Today, a similar storm could disable satellites, damage power grids, disrupt communications, and affect navigation systems worldwide. The economic and social impact would be massive and global. And the sun is becoming more active. Cosmic rays and DNA damage. High-energy cosmic rays originating from distant galaxies or unknown sources strike Earth constantly. While our atmosphere and magnetic field shield us from most, astronauts in space and airline crews at high altitudes are exposed to more. Cosmic rays can break DNA strands, cause mutations, and increase cancer risks. Over long timescales, they may even influence evolution. During solar storms, radiation levels rise dramatically, making deep space travel hazardous for future astronauts. Mars, with no magnetic field, is bombarded constantly. Understanding and shielding from cosmic radiation is a key challenge for interplanetary exploration. Supernova galactic shockwaves. When a massive star dies, it explodes in a supernova, blasting heavy elements and radiation across space. If one happened within 50 light-years of Earth, it could destroy the ozone layer, cause climate shifts, and trigger extinction events. There's evidence that supernova have impacted Earth in the past. Layers of iron-60 found in ocean sediments suggest a nearby explosion just a few million years ago. Betelgeuse, a red supergiant 642 light-years away, is expected to go supernova, not close enough to harm us, but a stark reminder of the potential power of stellar death. Micrometeoroids and high-velocity debris. Every day, Earth is hit by over 100 tons of dust and micrometeoroids. Most burn up in the atmosphere, but in space, these tiny particles can cause serious damage. At orbital speeds, even a grain of sand becomes a bullet. The International Space Station is armored to protect against such impacts, and satellites are often damaged or destroyed by debris. Micrometeoroid storms, clouds of high-speed dust left by comets, can intensify the threat. A large burst could disable key satellites, or even threaten future space habitats. Neutrinos, the ghost particles. Trillions of neutrinos pass through you every second. They rarely interact with matter, but they come from nuclear reactions in the sun, supernova, and the early universe. They're harmless to us now, but studying them could reveal hidden threats. Sudden increases in neutrino flux could signal a supernova before it becomes visible, acting as an early warning system for cosmic disaster. Psychological impact of cosmic fragility. Understanding how vulnerable our planet is can change how we see the world. Space isn't hostile because it hates us, it's indifferent. The universe is not designed for us. We are a fragile pocket of order in a chaotic system. For some, this is terrifying. For others, it's empowering. Knowing the risks allows us to prepare, to adapt, and to innovate. The more we understand space, the more we understand ourselves. How we protect ourselves now and in the future. Despite the risks, we are not helpless. Satellite shielding, early warning systems for solar flares, space weather forecasting, protective habitats for astronauts, nuclear-powered probes to monitor cosmic events. Future ideas include magnetic shields, deep underground bunkers, and even planetary deflection systems. The key is awareness and readiness. Should we be worried? The universe is dangerous, but so is life itself. Most threats are low probability, but high consequence. Understanding them helps us reduce risk. Many scientists are working to model, monitor, and predict cosmic hazards, and humanity has never been more prepared. The biggest threat is not knowing. The fragile miracle of Earth. We live on a miracle, a warm, wet, shielded world in the universe that is mostly empty, cold, and dangerous. Invisible threats surround us. But we're learning, watching, listening, building, and maybe, just maybe, that knowledge is our greatest shield. If this video opened your eyes to the power and fragility of spaceflight, subscribe and share it with someone who thinks the night sky is peaceful. Because out there, it's not silent,